Good morning, everyone. I am Sweta Sarangi, and in previous class, we have started our sixth chapter, that is our road drainage. So there are two types of drainage system in our roads. First one is surface drainage system, and the second one is subsurface drainage system. So in the previous class, I have taught you about the surface drainage system. Okay. So it provide for removal of water from the rainfall or other causes. It comprises the removal of, first one is water from the pavement surface and disposing of it. So here we can see this image. Okay. This is the carriage way, this is formation width, and here we can see the slope or gradient which is provided is parabolic in nature and parabolic in shape. That is why it is called as parabolic gradient or parabolic slope. Okay. So today we are going to study about the surface drainage system. So stability of the road surface depends upon the strength of the subgrade. That means our soil subgrade, because before in previous classes also I have told you about that the soil subgrade is the most important thing, because as we know that when we are constructing a building, as our foundation is the most important part of our structure, because we know that the entire load which are which which are coming from the superstructure to substructure, the load, only the foundation has to carry the entire load. So we have to prepare our foundation a very well manner, and and also we know that the foundation distributes the load to the soil mass evenly. In the same way, the road's foundation is our soil subgrade. So we have to prepare our soil subgrade in a good manner, and we cannot give a chance of drainage, or we cannot give a chance of seepage or permeability of water, and that's all. So we have to prepare our subsurface drainage. We have to consider that points also, because soil erosion can occur, and we know that the soil erosion is a major disadvantages to roads. So the strength of the subgrade depends upon the moisture content. As before I said, moisture content, like what's the moisture in it, okay, or what is the water content in it. The function of subsurface drainage system is to minimize the moisture content from the subgrade. The function of the subsurface drainage system. Why we are using subsurface drainage system? To minimize the moisture content or water content from the subgrade, because we have to keep away our subgrade from the water or from the moisture. Okay. Change in moisture content of subgrade are caused by fluctuation in the groundwater table, seepage flow, percolation of rainwater, and movement of capillary water. Main important points are fluctuation of groundwater table. We have to calculate this also. Then seepage flow, percolation of rainwater, and movement of capillary water, like capillary rise or capillary fall. So capillary fall here we are not considering. Here only we are considering the capillary rise. In subsurface drainage system, variation in the moisture content should be minimum by the application of following methods. There are some methods which we have to follow, like lowering of water table and all. Okay. So moisture changes in the subgrade occur due to the percolation of rainwater and seepage flow, as also due to the phenomenon of capillary rise. The aim of subsurface drainage is to keep the groundwater table, GWT, it stands for groundwater table, sufficiently below the level of the subgrade, at least 1.2 meter. When the water table is almost at the natural ground surface, the best option is to raise the formation of the roadway on an embankment is that such that it is 1.2 meter above the ground surface. Like our groundwater table is below 1.2 meter from the ground surface, and we have to provide our embankment of the road surface is above 1.2 meter from the ground surface. So if this is not possible for the reason of unfavorable topography, the only option is to lower the groundwater table by means of subsurface drainage arrangements. It must, however, be remembered that only gravitational water in the soil can be drained, but not held water, which is made up of the moisture film around the grains. Here we can see this is a subsurface drain and this is the subgrade soil. This is pavement and this is our normal road surface. As we can see that here we can say this is a combined curve, like here the some parabolic shape is here and also the straight lines, and this is shoulder. There are two shoulders, side drains, water, seepage flow, surface, subsurface drain, water table, etc. Okay. So there are two methods like lowering of water level. So what is that? The highest level of water level should be kept below the subgrade level. Okay. So that the subgrade and the pavement layer are not subjected to moisture. If the soil is relatively permeable, it may be possible to lower the high water table by constructing a longitudinal drain in it. Okay. If the soil is impermeable or less permeable at the middle of the pavement, lowering of water table is not adequate. In such case, transverse drains along with the longitudinal drains are provided to lower the level of water table. This is our how to control the or how to lower the water table. Next is what? Control of seepage flow. When the general as well as the impervious strata below are sloping, seepage flow is likely to exist. If the seepage zone is at a depth less than 0.6 to 0.9 meter from the subgrade level, longitudinal pipe drain in trench filled with filter material and clay sill may be constructed to intercept the seepage flow. We have to control the flow of seepage. Okay, clay sill also we can add into it. Here we can also consider the capillarity things. So control of capillary rise, if the water reaching the subgrade due to capillary rise is likely to be harmful, it is possible to solve the problem by arresting the capillary rise instead of lowering the water table. The capillary rise may be checked either by a capillary cutoff of any one of the following two types. A layer of granular material of suitable thickness is provided during the construction of embankment and in between the subgrade and the highest level of surface water table. The thickness of the granular capillary cutoff layer should be sufficiently higher than the anticipated capillary rise within the granular layer so that the capillary water cannot rise above the cutoff layer. Another method of providing capillary cutoff is by inserting an impermeable or a bituminous layer in the place of granular blanket. So these are the various methods to control or to provide subsurface drainage. Okay. Next is side drainage. So what is side drainage? In general, 0.6 meter to 0.45 meter triangular drains are constructed as side drain. In high rainfall area, drains of cross section 0.6 meter by 0.6 meter are basically provided. In side cutting, only side drains are made on hilly regions. Okay. So this is our side drainage, whose shape is in triangular drains are constructed of 0.6 meter to 0.45 meter. Here we can see the drainage. Next is side ditches. Side ditches collects the road water and lead it onward to the outlet ditch and are especially important when the road is wet. If the road is on high embankment, side ditches are not necessary. The longitudinal gradient of the side ditches should be at least 4% or 1 in 0.04. So the details of side ditches are the depth of the side ditches should be at least 30 centimeter below the bottom of the pavement structure. Deeper ditches greater than 30 centimeter do not significantly improve drainage. Okay. So this is side ditches. Here we can see the image of side ditches. Mainly here we are this ditches providing where the road surface is wet. In the next class, we are going to study about the function suitability. Okay. Thank you.